Hello friends, welcome to Code Sutra. In this video, we will be solving LeetCode problem number 1569. Number of ways to reorder array to get the same binary search tree. So let's understand the problem step by step. Say you are given this array and you want to form a binary search tree. How do you form? The first element will be the root element. Then 4. Since 4 is greater than 3, it should be on the right part. So we'll put it on the right part. Then next, what is the element? 1. Since it is lesser than that, we'll put it on the left. Then again we have 2. So we'll go to the left. Again, since it is greater than 1, we'll put it here. Again, 5, we'll be putting it on the right side. So this is how we form a binary search tree using an array. Let's take another example, the same one. 3, 4, 5, 1 and 2. The same binary search tree will be formed here. 3, 4 and 5 will go here. 1 will come here, then 2 will come here. So if you look here, this array and this array, though they are different, led to the same binary search tree. So we have to find the number of ways in this array can be formed, which will actually lead to the same binary search tree. In this case, the answer will be 5. Excluding the original array, it will be 5. So we have to find the number of ways the same binary search tree can be formed. So let's dive into the problem. For example, if you look here, what is more important here? The order of these two elements is more important. The order of these two elements is more important. Say if it was 2 and 1, that is it was 3, 4, 5 and 2, 1. What it would be like this? 3, 2 and 1. This is actually not equal to the original binary search tree. So the order of the elements is more important here. So if you look here, what we can do is we can fix the positions of 4 and 5 and the remaining we can just put 1 and 2. Similarly here also we can put 1 and 2. But the relative order of 4 and 5 is important. So once we have fixed 4 and 5, 1 and 2 can be arranged. So let's forget about 1 and 2 and the order of which, but let's focus on the order of 4 and 5 here. Where 4 and 5 can be put here. So this is the original array. If you look at it, 3 has to be fixed at the first position. Why? It is because the root node. Then we have 4 more positions to fill and 4 can be put here, 5 can be put here. Similarly, 4 can be put here, 5 can be put here, 4 here, 5 here, 4 here, 5 here, 4 here, 5 at the last, then again 4 and 5. In simple words, what are we doing here? We are doing nothing but we are taking 4C2. Or in other words, how many elements are there on the right subtree and how many spaces are left, that is equal to n minus 1 C on the R, where R equals to number of elements on the right subtree. So that is what we are doing here. So why is it so important? First we fix the position of these two elements and we will also be fixing the position of other two elements. So the number of ways in which this can be arranged, that is 4C2 will be equal to 6. That is 4 factorial by 2 factorial star 2 factorial. That is simply equal to 6. Now we have to subtract 1 out of it. Why? Because this was the original array and this is included. So our answer will be 5 in this case. So this is a very simple problem, but let's dive into a bigger problem. Right? For example, let's assume this entire tree that we just constructed here is equal to left subtree. And we have one more subtree, that is the right subtree. So this can actually be formed using this array. Now let's look at one more solution. Now we have this position of 7 is fixed. Now let's arrange these 5 elements. What is the options to arrange these 5 elements? The options to arrange these 5 elements out of this 10 position will be equal to 10C5, which is again equal to n minus 1C, whichever is on the left. It can be L or it can be in the number of elements on the right hand side. So this, after that, don't forget, we have to multiply whichever was on the left side, the number of elements on the left and into the number of elements on the right. Why are we doing this? First, these are the elements that can be arranged, right? And after that, even say for example 3, you fix this 3, 1, 2, 4 and 5. So whatever can be arranged in these two positions, all the remaining 5 positions, these again can be arranged in R ways, right? That is the number of ways that these can be arranged. This again can be arranged in 6 ways. This can be arranged in 6 different ways. So not only are you fixing the position of these 5 elements, but also the remaining 5 positions can be filled in 6 different ways. So what are we doing here is, we are just multiplying the number of ways that left can be subtract can be done and the number of right can be done into the number of ways these positions can be filled. That is 10c into left or 10c into r. So that is the steps that we'll be following. Let me explain the steps that we did here. First thing is, we'll fix the root node. That is, the first element will be the root node. Fix the root node. What is the next step? We'll be dividing the remaining array. For example, this remaining array will be divided into 2 parts. That is, all the elements less than root will be left. All the elements greater than will be in the right subtree. So now we know the number of elements on the left and the right. Again we will be calling the same function. That is, we will have a helper function, and again we will call the same function using the left array, and also we will be using the same function to call the right array, and both of them will be multiplied with by NCL. So this is the step. And again, how do we do this? This is a recursive problem, and this will again go. For example, if we look in this particular problem, what we did, we considered the entire subarray and we just called for this subarray, and then again we called for this particular subarray, then we just multiplied both of them. So this will be our steps. So what we do here is, we split the array into 2 parts with the lesser elements and with the greater elements, and we just multiply them with NCL. So that is what we did. But now, should we calculate NCL at every step? The answer is yes, you can calculate NCL at every step. Or one more formula that you can do is, you can construct a table using this simple formula, that is NCR is nothing but n minus 1 CR star n minus 1 CR minus 1. So this simple formula you can construct in this table. If you look here, what are we doing here is, we will just n minus 1 CR plus n minus CR minus 1. That is these 2 elements. If you look at this 10, how did we arrive at this 10? 6 plus 4. Again this 10, 6 plus 4. This 5, 4 plus 1. So using this table, we can easily construct this formula. Since it is used repeatedly, constructing this table will save a lot of time. So let's dive into the code part. The first thing what we are doing here is, if the number of elements is lesser than 3, straight away we can return 1. The next thing we are doing is, we are constructing 2 different arrays, that is left and the right, and whichever elements are lesser than the root node, we are adding it to the left array, and whichever is greater than, we are adding it to the right array. So if you look here, again we are calling the same function. That is the same function we are calling with the left subarray, and we are calling the same function with the right subarray. Why are we doing %mod? Because the answers can be very large, so we are doing this to avoid overflow. Then finally, what we are doing here is, we are getting the NCL or NCR value from the table. How do we construct the table? We have let me dive into the code later. But once we have got this value, in simple, we are multiplying these 3 values and we are returning the final value. It's a simple solution here. So how do we construct the table? It's a simple table. We are using this formula, NCR is equal to n minus 1 CR star, plus n minus 1 CR minus 1. That is, we will be using this formula and we will be constructing the table. Once we have constructed the table, we will be calling the function for the entire array. So finally we have the answer. Please do comment in the section what will be the time complexity and what will be the space complexity. Thank you for watching the video. Please do like, share and subscribe.